Alrighty, welcome back, boys and girls. It's your main math man, Mr. N, coming to you live from Mayfield. In this video, we're going to be working on that slope and y-intercept using those notes that we just talked about, but we're going to try to get some more practice with it. So we're going to try to make some connections to what we know from previous topics. So we're going to use those ideas that we had from scatter plots, where we talked about correlations. And so we were given those three different correlations from before, and now we're going to have those three different slopes. And so it says, as a line with a positive slope slants up and to the right. And so again, I kind of notice like this. Let me actually see if we can draw this out. It's saying that it goes from left to right, it is going up. And so you have to notice that it is pointing up in that direction. Where if a line with a negative slope slants down and to the right. And so as your x values increase, your y values are now decreasing. So again, just notice as those graphs are a lot easier to see. And the third case is a little bit different. It's going to be a line with a slope of 0 is going to be horizontal. And so you can kind of tell as well with that, you're just saying, hey, it's just when y equals a value. So it's just anytime y equals and then a number. If you don't have your input in it, meaning your x value, it's just saying, and regardless of any x value, your y value is always going to be the same. So it doesn't matter what your x is. If it's horizontal like this, it's just going to be y equals a number. And so the way that's going to work is to further our understanding of these functional conceptions, we want to be able to do some practice just like anything else. However, I want to make a compromise. So I'll give you the first example, like you're shown. Next, we will do the middle one together. And then finally, it will be your turn and your turn alone to see what you can do. And so in the first scenario, it says, given a table, identify the slope and y-intercept. Again, with your table, it has the x values on the left and your y values on the right. If it's a horizontal table, maybe something like this, it would have, your x on top and your y on bottom. Either way, it still works out like this. You would say your x values are here, and you're saying, okay, what is it increasing by? Well, our x values, it is following the pattern where it is increasing by one step. And then for the y values, however, it's saying that it's decreasing by 3. Again, you only really need 2 points, any 2 points to notice the pattern, but we can kind of show the pattern after that. And so again, our slope is going to be equal to the change in y, which is -3, over the change in x, which is +1. Again, be careful when you are writing these ratios or fractions. You want to make sure that you can simplify it as well. So that way, when you go to write your equation, it's just going to be a nice, simple value. Again, it could be a rational number, meaning it could be, 1/4 or anything like that, but you want to make sure it is in simplest form. So for this slope, it is -3. When you're looking for your y-intercept, you want to make sure you can look for the point where x equals 0. So I usually just highlight the value where x equals 0, and I say, okay, my y value is going to be 2. So that's where that line of our function hits the y-axis. All right, so one that we can do together gives the values for x and y, and so it has our x values as -2, 0, and 2. And then it has some larger y values, but it has -19, -3, and +13. And so we're going to say, what is our y values increasing by? Well, how do I go from -19 to -3? Well, I'm going to be increasing, meaning I'm going closer to 0. And then how would I go from -3 to 13? Well, I'd have to increase in steps of +16. So I'm going to have that my y values are increasing by 16, and then I can see that my x values, well, they are increasing by a +2. So I'm saying that for each of these two x's, I have a +16y. So again, I put that in for my slope. I have my change in y over my change in x. And I say, okay, what is my change in y? Well, it's going to be +16, and my change in x is going to be +2. You want to make sure that you can simplify that out. So I have 16 divided by 2 is going to be a +8. So my slope for this function is going to be 8. Then I look for the y-intercept in this one. Again, I highlight where the x value is equal to 0, and I say, all right, well, if x equals 0, my y value is -3, and so that means my y-intercept is going to be -3. So the slope for this function is +8, and the y-intercept is going to be -3. And so now on your own, given this table, make sure you can press pause. You can press K to pause the video and try this out on your own. In the second scenario, it says, given a function in the y equals mx plus b form, identify the slope and y-intercept. And this one is a pretty simple scenario as well, but we want to make sure we can give a couple of ideas with it. So it has y equals -3x plus 2. And so again, I highlight in green where my slope is going to be. So my slope for this is going to be -3. And then I highlight in orange where my y-intercept is going to be. So it's going to be a +2. You want to make sure that you are including that sign with it. So again, if it is a negative slope, you want to say that it's going to be -3. If it's going to be a negative y-intercept, you want to make sure that you're saying appropriately. So for this one, again, it was -3 and +2. All right, for one that we can do together, again, what this function gives it like this. It says y equals 6x minus 1. And so I can highlight in green. I can say, all right, I know my slope is going to be 6, so I have +6 as my slope. And then I highlight the y-intercept as -1. So I'd say my slope for this function is +6, and my y-intercept is -1. And the one that you can try out on your own, again, it says y equals -1/4 times x plus 30. So again, make sure you can press K to pause and try it out on your own. All right, and the third scenario is going to be a little bit tougher, but it is just as simple. So now, given a graph, identify the slope and y-intercept. And we talked about this in the notes, but I want to have a more clear example of that. Anytime you're given a slope, again, you kind of think of that incline. So you're thinking, okay, if you think of a ramp, you have a nice perfect straight line, and the staircase, so if you had a set of stairs, you want to make sure they are equally spaced. So that means this. It's saying for each y value that I have, so I'm having I have that my y value is increasing by 1. For each 1 y, I have 3 x's, so I'm going to the right 3 steps. So I go up 1, 3 steps to the right, up 1, 3 steps to the right, up 1, 3 steps to the right. And you want to make sure, the reason where I'm placing these points is like this. I know that that line hits exactly at that point, or that ordered pair, -3, -4. I'm able to tell that because it is directly in the corner of that box. So I know that, again, for my y-intercept, I highlight the y-axis, and I can say, hey, boom, right there's my function, there's the line for my function, and it hits the y-axis at -3. So again, very simply, I have my slope for this is 1/3, and my y-intercept is -3. All right, for the one together, you want to make sure that you can plot out your y values. So I'm going to say, all right, let's start in the far left. So let's see, I want this and that one like so. I'm going to say, all right, I have from this point, I go down 1. So again, I'm trying to see, let me see, where am I here? So I'm going from the far left, and I need to see, okay, where does that go? Well, it is directly in the corner here, so I know I can say this order pair of -6, 6 is a point, and then I can go down to the next spot where it is directly in that corner. So you want to make sure that you're careful. You want to make sure that it is, it's not really in another line, or it's not halfway in between. It's directly in a corner of an intersection. So I can say, okay, if I'm going down 1, so I want to go down 1, and I want to go over, so I'm going to go blue. I'm going to say, okay, now I want to go over, let me see if I can try this out, over 2. So again, I'm saying this, I'm saying for each y value that I'm going down, I'm adding, or I'm increasing my x values by 2. Again, make sure you can see this full screen. If you need to press F to hit full screen, please do. So I'm saying for each y value I'm going down, I'm going to the right. So that means the same pattern is going to be like this. So again, I can kind of make some adjustments here. So I can go down 1 over 2, down 1 over 2, so on and so forth. Again, you should be able to notice the pattern that's going along with it, and you should be able to kind of connect and make a perfect looking staircase like the carpenter that you are. So you want to make sure that you're saying for each y value I have, for each -1 y value, I'm increasing my x value by 2. So I have it just like this. I have -1 plus 2, -1 plus 2, so on and so forth. Again, this helps us kind of see the pattern and the function exactly how it's supposed to look. The reason why I kind of draw this out very carefully is I want to make sure that I'm hitting ordered pairs on the graph, and I can see what the pattern is. So what does that mean? Well, that very simply means this. It's saying that my change, or my slope for this function, is the change in y over the change in x. And so I can say, all right, well, what is that amount? We said it's going to be a -1, so let's have this. Let's say it's going to be -1. Make it a little bit smaller. It's going to be a -1, and it's going to be over a +2. So let me have a positive 2. So again, our change in x was +2, and our change in y was -1. So that means this, when we go to simplify that, you want to make sure you just can write that our slope is -1/2. If you wanted to use a decimal, you certainly could, but if it asks for a ratio or a fraction, you want to make sure that you can hit that appropriate amount. The normal question that comes along with this is, well, does it matter where my negative goes? Well, not necessarily, because it's a ratio between two numbers. So if it says I have a -1 up here, it is the same as having it outside, and it is also the same as having it on the bottom. Again, the reason why this works is because if I was to look at this last one here where it says +1 over -2, I could just go to the left now. So I'm going back 2, up 1, back 2, up 1, and it still works out. So again, either way, it is fine. To make sure I can identify what that y-intercept is, very first thing you should do before anything else, before even finding the slope, is just highlight that y-axis and be able to say, okay, where does our line or our graph of our function hit the y-axis? So again, I say, okay, well, this is our line and it hits the y-axis at the point positive 3. So I can say our slope for this one was -1/2 and our y-intercept was positive 3. And so again, for your turn, make sure you can highlight the y-axis to find the y-intercept and make that staircase that we've been doing. So again, press K to pause. And in that fourth scenario, again, it says, given the slope and y-intercept, write the function in the equation of the form y equals mx plus b. So again, this is a rare case, but it's also very simple. You want to make sure you can read it carefully. So it says there's a line whose y-intercept is 3 and whose slope is 10. What is the equation, or what is its equation in slope-intercept form? So again, it's always going to be in that form where y equals slope times x plus the y-intercept. So it has, again, I highlighted it very simply. Our slope is going to be 10 and our y-intercept is 3. So the function would be read as y equals 10x plus 3. So the one together, it says a line's y-intercept is -10. So I can highlight that part right there and say, hey, I already know I'm going to have a -10 back there. And then our slope is going to be 8. So I can say our slope is 8. Again, make sure if you wanted to write if you wanted to instead have the minus and then say 10 right there, you certainly can. But you want to make sure that you are including that negative. So if you were to say plus 10, that would be incorrect. So it's going to be y equals 8x plus a -10, or you could say y equals 8x minus 10. Either way would work. Again, for your turn, again, make sure you're reading this carefully. It says a linear function has a y-intercept of 3 and a slope of 4. Write the equation to represent this function. Once you have that written, make sure that you can graph the function for that equation. So once you have this function written out in slope-intercept form, be able to plot it on the graph and check out your work.